System interconnection. Since system interconnection is the connection between the two components of the system or two sub-signals. So here H2 of n and H1 of n are two signals, and if they are connected in this fashion, it is referred as a parallel combination, and this parallel combination is represented by the plus sign. It is H1 of n plus H2 of n. The effective solution, the simplified diagram of this one is H1 of n plus H2 of n. So it can be represented as a single function with the transfer function H1 of n plus H2 of n. And similarly, when we have the two blocks in cascade form, then the effective solution of this one is H1 of n convolution with H2 of n. So by using these two, it is a series combination, and the first one is the parallel combination. Using these series and parallel combinations, we can solve any type of the interconnection of systems, and the same applies to continuous time signals also. So if the signal H1 of t, if it is, and another one is H2 of t, then their parallel combination is the sum of these two, so which will be represented by H1 of t plus H2 of t. And similarly, the series combination, which will be represented as H1 of t in cascade with H2 of t, is H1 of t in convolution with H2 of t. Now we are given with a problem wherein the values of H1, H2, H3 and all are also given. So we need to simplify this interconnection of systems, and we have to write it as x of n. We have to write it as the total transfer function of the system in the bracket. Let's say that is h of n, and x of n is the input to our system, and y of n would be the output. So we have to write it in this fashion, and for that we need to simplify these. And now we can see this y of n is equal to what? Y of n is equal to this all x of n in the bracket in this block. It has to be this all. So let's solve what is this h of n first, and then we can use that. So our h of n means the total transfer function of the system is h of n is equal to so these two are in parallel, so these can be written as h1 of n plus h2 of n. So let's write this one is h1 of n plus h2 of n, and these two are with plus signs, and even this one is with plus sign. So if there is a plus sign, then they both are positive. Now this combination is in series with this. So this diagram looks in this way. When we solve this H1 and H2, the parallel combination, the diagram looks in this way. Now here H1, H2, this combination can be thought of as a single function and single signal. We can go for solving this one. Now this above diagram becomes, the solution becomes H1 of n plus H2 of n in convolution with H3 of n. And when we go for solving this one further, our system becomes H1 of n plus H2 of n in convolution with H3 of n, and this all combination minus H4 of n. Now let's substitute the values of H1, H2 and so on, and find what is the value of H of n. So for this, h1 of n is u of n. So let's write u of n plus h2 of n is u of n minus u of n plus 2, u of n minus u of n, u of n minus 2, then this bracket u of n plus u of n minus 2, this in convolution with h3 of n. h3 of n is del of n minus 1. The value of h2 of n is u of n plus 2 minus u of n. So let's substitute the value of h2 of n as u of n plus 2 minus u of n. Then convolution h3 of n. h3 of n is del of n minus 2 and minus h4 of n is a raised to n u of n. So when we go for solving this one, we can see it is u of n and minus u of n gets cancelled, and u of n plus 2 is convoluted with del of n minus 2. When u of n plus 2 is convoluted with del of n minus 2 by using the time shift property, because any signal convoluted with del of n signal will be the same signal, so the result of this one would be u of n plus 2 and this minus 2 minus a raised to n u of n, a raised to n u of n. Now u of n plus 2 minus 2 will give u of n signal itself minus a raised to n this u of n. So from this we can take up u of n common, and the answer can be written as 1 minus a raised to n u of n. We can see the next problem. Let's see the system. Here we are given with another system wherein the interconnections are there. We need to find what is the transfer function of this entire system, where x of n is the input and y of n is the output, and the values of h1, h2, h1 of n, h2 of n, h3 of n and h4 are given. Now the transfer function of this system, now we can see that h3 and h4 are parallel to each other, so we can write h3 plus h4, and these two come in series with this h2, so h3 plus h4 in convolution with h2, and this all combination is in parallel with h1. Then the system function becomes this one. Now we can go for writing this solutions, like we can substitute the values of h3, h4 and h2, h1. So it is h3 del n, h3 is 2 del n, h4 is minus 2 half raised to n u of n, and now these two are in convolution with h2. h2 is 1 by 2 del of n minus 1 by 4 del of n minus 1, and this plus the h1. h1 is del of n plus half del of n minus 1, and when these are solved, we'll get this 2 del of n, as it is a subtraction. So let's go for solving this. So the convolution of these two h3 and 2 del of n is convoluted with this term, and this minus 1 by 2 raised to n u of n is convoluted with this term. So distributive, commutative, this convolution is distributive and even commutative, we are using those. So this term is convoluted with this entire and even the second one. And then last expression is as it is, del of n plus half del of n minus 1. Del of 2 del of n convolution with half del of n is nothing but this 2 cancels del of n itself, and 2 del of n convolution with 1 by 4 del of n minus 1 is 1 by 2 del of n minus 1, and this 2 1 by 2 raised to n u of n convoluted with this is nothing but, again this 2 cancels, it is 1 by 2 raised to n u of n itself, and this 1 by 4 will become 1 by 2 half raised to n minus 1, because this 1 by 2 will remain by considering that. So it's 1 by 2, 1 by 2, and del of n minus 1 is there. So time shift property, this half raised to n u of n multiplied with convoluted with del of n minus 1 will make it as half raised to. By using the time shift property of convolution, we'll write this one as 1 by 2 raised to n minus 1 u of n minus 1 plus del of n plus 1 by 2 del of n minus 1. So this half del of n minus 1 is cancelled with this, and the remaining term is this one, and when we go for solving this one, we get 2 del of n terms, half raised to n u of n, and this 1 by 2 raised to n by considering this 1 by 2 u of n minus 1. This is the solution. Solve such kind of problems, and we'll discuss the next problems in the next video.